In this tutorial, we're going to walk you through the nesting feature in the software to achieve maximum usage of our available material. We'll take you through several scenarios, each demonstrating different options and which ones would work best for the type of job that you may be running. So let's go to File, Close. So let's go and open an existing file. And from the Nesting Guide project folder, we're going to open the olympicstadium.crv file and press Open. So this is a sign where we have a border and all of the letters for the Olympic Stadium sign. Now we've been asked to create two lots of these signs where we have one piece of material that is 48 inches by 48 inches. So how do we go about creating two copies of this using the material size that we have here? Now, one way that we could do this is just by manually creating copies of these vectors and then manually organising them into the workspace that we have here, or we could make use of the nesting feature. So to do that, we're just going to select all of the vectors. I'm just box selecting those so that they're now all highlighted. And the nesting feature can be found at the bottom over in Offset and Layout, and it's the last icon, Nesting Nest Selected Objects. And if I click into that, that will open up the nesting tool. So here we have a form that allows us to control the different settings that we may want to apply when nesting our parts. So let's start off at the top where we've got Tool and Clearance settings. So the first option is the tool diameter. So this needs to be the tool that you're going to use to cut the shapes out. So in this case, I am using a 1/4 inch end mill, so I'm going to leave that set to a 1/4 inch, and that will leave a minimum of a 1/4 inch between any of the parts that are cut. Then we have the clearance. So you may want to have a bigger clearance between the parts to preserve any cutting finishes that we apply when we come to do the toolpaths, that being either climb or conventional milling. So if two parts were only a 1/4 inch apart, which is the same as the diameter of our tool in our case, when the tool will be cutting out one of the parts, it will also be cutting what would be the finish of another part. So we may want to add in an additional clearance as to not touch the finish of another part. Or we may just want to add in the clearance to add tabs to hold our parts in place. So here we can specify an additional clearance onto the tool diameter. So here we're going to put in a clearance of 0.35, so 0.1 bigger than our tool. That way we're going to have a maximum of 0.6 between all of the parts that we are cutting. So this would mean that we'd have a minimum gap between any toolpaths that the tools may take. There'll be a minimum gap of 0.1 in between each of the paths. That will be built upon two lots of 1/4 inches, so for example outside the O, outside the L, and then the gap between each cutout or the edge of the tool will be 0.1, which will then build up to the 0.6 inch minimum clearance between the letters. Let's just press F to fit that to screen. I'm just going to highlight those. So we've got the clearance there of 0.35. And the last option that we have within the tool and clearance settings is the border gap. So this is the margin applied around the entire edge of our material, which helps with our hold down method not being interrupted. For example, we may want to clamp the material down or screw the material down into our spoil board. So in this case, I'm going to apply a border gap of 1/2 inch as I plan to clamp the material down. Now the next section that we have is the part nesting options, where we have different methods that we could use to arrange the vectors that we've got selected to best fit in the space that we have, just to really efficiently make use of the material that we've got. For now, I'm not going to select any of these options. I'm just going to uncheck those, and we'll just see how the software nests the part using the options below, which leads me to the sheet options here. So here we need to specify where we nest from, so we choose a corner of our job space. So I'm going to leave that set to the lower left hand corner, so it's going to nest from this area here. And then we choose the nest direction, whether that's going to be along X or along Y. So I'm going to use the along X option. individual part properties. Okay, so here we can specify the number of copies. Now I want 2 lots, so my customer wants 2 signs, so I'm going to put in 2 in there. I could type that value in or just use the arrow keys, and then I could press apply, and you'll notice now a number 2 has appeared around the areas of the vectors that we've got selected there. So it's telling us the number of copies that it will create when we go ahead and press preview. So let's just go and preview that. So initially, to look at the part, it doesn't look too bad. However, I can see that I have another sheet. So if I just zoom out here, you'll see that we are now presented with a second sheet. Okay, so we've got letters that have overspilt that couldn't fit on our first sheet and have now been positioned onto a second sheet. I can double click on sheet 2 to activate that, so you can see that we are now looking at sheet 2, and to go back to sheet 1 I could double click on sheet 1 there. Not only can I do that, I can go to the active sheet here, go to the drop down, and you'll see I could press 2 and then I could go back to 1 just to change between each of those sheets. Now, taking a look at our part, so the centre of our sign is essentially going to be waste material. So what we could do is we could look at using this area to create more letters, and so we can use the internal space of the sign border to input all of the overspilt letters to save us eating into another sheet there. So let's have a look at how we could do that. So if we just press F just to fit that to the screen, I'm just going to reset that preview, and again we'll just press F again to fit that to screen, and this time we're going to come over to the part nesting options. So we're going to look at this option here to allow parts inside of other parts, and so it will detect that this area here is going to be waste material and that it will make use of this space to fill it with what objects it can. So let's go and check that, and then again we'll go to the same settings and we'll just preview that. And so you can see here that what it's done is it's put all of the letters inside of what is essentially the waste material. And you'll see here that I now have lots more space for other jobs too. So from the same customer, I do have another job that needs cutting out. So I can see if I can combine that with this job to really make use of my material. So let's just reset the preview. We're just going to cancel out of the nesting tool. So if I go to the layer manager at the top here, I'm just going to temporarily undraw the visibility for the Olympic sign and just switch on the visibility for this fast food layer. Now I'm just going to select the word fast food there, and I'm just going to nudge that up just using the up arrow key, so just moving that up there, go back to the Olympic sign layer and switch that on. Then we're going to select all of the vectors there, so including that fast food extra job that we've been given from our customer. I'm going to go back into the nesting form, and then we'll go with the exact same settings that we used before. Number of copies, we want to put 2 in there. We could go ahead and press apply, and then we could preview that. And so we can see here that all the vectors for 2 jobs are now on the same sheet, and this will make this job more profitable as we are maximising the use of the material that we've purchased to create this job. So now what we could do is apply a quick profile toolpath around these vectors, and we can demonstrate the tool diameter and the clearance gap between each of the parts for a better visualization of the tool and clearance settings. So let's just go ahead and press OK to accept those changes. I'm going to go over to the Toolpaths tab. As with any toolpath, we must remember to check our material setup before we go ahead and calculate any toolpaths. So you just want to check that all the information is correct to how you're going to set that up on your machine. I'm happy with that, so we could go ahead and press OK. So I'm going to box select all of the vectors there, and I'm going to come over to the profile toolpath. Start depth is at 0. Cut depth, we're going to cut all the way down the material, so I'm going to put in Z equals, and it'll put in that 1/2 inch material thickness that I had specified in the material setup form. So then we need to select a tool, so we're going to use the 1/4 inch end mill as I mentioned earlier. Machine the vectors on the outside, can come down, you could give that a name if you wanted to. In this case we're just going to calculate that as it is, and then we could just simply go ahead and preview that toolpath. And here if we wanted to, we could just go in and delete that waste material. Now what I wanted to show you here is the gap between the toolpaths and the clearance that's available while cutting. And so to show you that they're not going to be too close, so you can view this better in the 2D view. So let's go into the 2D view and switch on the visibility of our toolpath. So if we just press F just to fit that to our screen, we can see the direction of our toolpath where it's going to go. But if we come over to this icon here, so we're currently in the wireframe mode at the moment. If I click on that, it's going to put that in the solid preview. And so this is going to give us a solid representation of the tool's cutout. And so if we just zoom in over here, we can see the 1/4 inch tool represented by that purple colour, and then we can see that we have a gap in between each toolpath, which is a minimum gap of 0.1, which we could use for tabs or just to keep it out of the way of affecting the finished areas. So now we're going to look at another example of nesting. So let's just close this down and we'll go to File, Close. I'm not going to save this, I'm just going to press No here. And then we'll go and open an existing file, and from the same project folder we're going to open the nesting example and then press Open there. So here you can see that we have some vectors to the right of our job, and we're working with a job size that is 48 inches by 48 inches. So we want to create 25 copies of each of the vectors to put onto our sheet. I'm just going to box select these vectors for this component here, and with those selected, let's go over into the nesting feature. I'm going to go with the same settings as before. Part nesting options, we're going to make sure they're all unchecked for this example. I'm going to nest from the lower left corner along X, and then we could go and put in a number of copies. As I said, we want to create 25 there, and we could simply go ahead and press Apply. And then we could preview that, and we can see that we've got our parts. I can also see, judging by the view here and looking at the active sheet, I can see I've got 2 there. If I zoom out, we've had an overspill there, and we've got 5 extra components on sheet 2. Okay, so again, double click to switch between those sheets there. So let's just have a look at another way that we can nest these vectors. So we'll try and nest them so that they can all fit onto one sheet. So over into the part nesting options, what we could do is we could look at using the mirror parts to find best fit. So let's just reset that preview. Just press F just to fit that to screen. And then we'll look at using this option here to mirror parts to find best fit. So we'll check that, and we'd use this option if we weren't too concerned with which side of the part is the top side. Some materials have a finished side and an unfinished side, so you'd have to bear that in mind if you wanted to mirror the parts to best fit the material. So with that checked, let's just go ahead and we'll preview that. So again, you'll notice, again, we still do have an overspill. We've got 2 components over here on sheet 2 that haven't managed to fit on our first sheet. And if you just take a look at that first sheet, you'll notice that parts have been nested along the x-axis, and then where it's got to the end here, the software can no longer create a new row, and therefore it will try to mirror the parts to best fit in the space that we have available. So now let's have a look at another option to see if we can better fit our parts into the material. So let's just uncheck that option, and we'll go ahead and we'll just reset that preview. And so here we could look at rotating the parts to find the best fit. So I'm going to check that option. I'm going to put in a rotation step angle of 45 degrees. And so what the software will do, it will rotate the vectors in increments of 45 degrees to best fit the parts into our space. Now you may need to think about the importance of the direction of the grain when doing this, if you wanted all of your parts to have the same grain direction. So go with 45 degrees there, everything else can be the same, and we could go ahead and simply apply that, and we can preview that, and we can see how it's rotated some of those to 45 degree increments. You can also see we have another sheet where two of those components have been overspilt. So again, let's just have a look at how we could better fit all of the parts so that they go onto the one sheet. So what we can do is look at reducing the rotation step angle if we wasn't concerned with the grain direction of the material, to see if we can really maximise the material usage. So if the grain direction is not a concern, then we can lower this rotational number to as low as 1 degree, and so it can rotate each of these vectors 360 times using the 1 degree step angle to find the best fit for our sheet. So with that in there, let's just go ahead and we'll just reset that preview. We've got 1 degree in there. Let's press apply, and then we can preview that, and we can see now that we've changed the rotation step angle to increments of 1 degree, that all of the parts now fit within our one sheet. So there we've demonstrated various ways of really maximising the space that we have available to us. So let's just reset that preview, and we're going to look at another example. So we'll just cancel out of the nesting form there. Just click into the white space. Now let's imagine that we only had this size material available to us. And now what I'd like to do is I'd like to cut 5 lots of these vectors that we've got here. Now as always, to maximise the remaining material, we should always use the nesting feature. So those vectors selected, let's go over to the nesting feature there. And so we're going to go with the same settings that we used before, except this time number of copies is going to be 5. So we could press apply, and we could simply preview that. So you'll see it will create 5 copies of each of those parts, and we've got them at a rotation step angle of 1 degree going along the x-axis from the lower left. And so you can see we've really cramped everything in towards the left as we can. So we've got all of this space available here. Now let's imagine that we've ran this job on our machine, and now we want to make use of the remaining space here. So how can we nest further objects into this particular space that we've got available to us on the right hand side? Well, let's just OK that. And to do that, we're going to come in and we're going to draw a rectangle. So I'm just going to roughly sketch in a rectangle like so. Okay, so that pretty much fills the majority of the right hand side there. And we can close that down. Then what we can do is we can select these vectors here. So these are the final vectors that I'd like to nest. We'll come over to the nesting tool. And then I'm going to shift and select this rectangle that we just drew out that represents the extra space that we have on the right hand side. So remember, we've already cut these parts out, and this is the area that we're left with on our material. So that vector is going to act as a boundary. So we're going to check this option here. Last vector is nest boundary. Number of copies, we'll put 5 in there, same settings as before, and we could just simply apply that, and we could go ahead and we can preview that. And we can see that all of our parts have been efficiently placed within this rectangle that we use as our boundary in order to nest the remaining parts. And so we still have extra space on the right here, and this just demonstrates how we can plan ahead with the jobs that we are given to really maximise the usage out of every piece of material that we use, resulting in more profits in the long run. So let's just cancel out there. We're going to close this file down and we're going to look at another example. So go and open an existing file and we're going to open up the widget vector.crv file and then press open. So here we have the Vectric widget. And so the part has been set up in such a way where we've got various layers, and each of these layers has specific vectors applied to it. So if we go to the outline shape, see we just have one vector that represents the outline shape. Recessed rectangles has the recessed rectangles. Then we've got text, which has the text on, and then the drill holes layer has all of the vectors that represent the drill holes. And so if we just switch those on and switch over to the Toolpaths tab, and so the part has been set up in such a way where all of the toolpaths are associated with the vectors on the layers that I've just shown you there, using the automatic vector selection option. And that's where we associate specific rules to the toolpath. For example, if I go into the drill holes toolpath, you can see the vector selection option is set to automatic. So if we go on to the vector selector there, we can look at the rules that are being applied to this toolpath. So we've chose to specify all the closed vectors and only circles on the selected layer, which is the drill holes. And so you can see it's got those drill holes selected there. And we're associating that with the toolpath. It's going to find all of these rules and apply it to this toolpath. It just helps us to automatically select the vectors that we need rather than going in and manually selecting each one of those vectors. And there are other tutorials that cover the setup for the automatic vector selection in much more detail, and you can find those videos in the related videos section for this tutorial. And so each one of these toolpaths is associated to vectors on a particular layer, like I showed you earlier. Now I could cut this one out as its own as a prototype, so let's have a look at the preview. So we'll go to the toolpath preview. We've got all our toolpaths there. Let's preview all of the toolpaths and we can see the different toolpaths in there. We've got our pocket rectangles, the drill holes, the text, and then the actual profile cutout. And so having the part set up this way, where we let the software pick the vectors for us by applying various rules, means that at some point in the future where I may want to mass produce this part, I can simply nest the vectors that we have here using the nesting feature. And because the toolpaths are associated with vectors on particular layers, all I have to do is simply recalculate the toolpaths without having to manually add in the copies of the nested vectors to each toolpath. And the software will automatically do that for me. So let's have a look at how we can do this. So we'll just close out there. We're going to go into the 2D view, and then we'll just switch over to the design tab. I'm going to go into our job setup here, and we're going to change the job dimensions. So we're going to make that 36 in width, 36 in height. I'm going to go and press OK. So here we're just going to select all of the vectors here, and we're going to come in and use the nesting feature. So go into the nesting tool. So here we're going to specify a tool diameter of 1/4 inch. Clearance for this, we're going to go with 0.5. We're going to have a border gap of 0.25 in this case. So here we are going to look at rotating the parts to find the best fit. We'll put in a rotation step angle of 90 degrees. We'll come down the form. We're going to nest from the lower left along the x-axis. We're going to put in 18 copies of our widget there, and then we could simply press apply and we can preview that, and we could see that we've got our parts here. I can see straight away that they've not all managed to fit on the one sheet. We've got two that have overspilt there, so what we could do is maybe looking at reducing the step angle. So we could put that to 30 degrees and Well, first we'll just reset that preview, put that to 30, then press apply, preview that, and again we're still missing one widget there, and so what we could do again is just look at some other options that we could alter to ensure that they all fit on the same piece, just to really maximise the amount of space that we're actually using. So let's reset that preview. We could get away with just reducing the clearance gap, so we'll make that 0.4 instead, and then again we could just apply that and then preview that, and we can see that all of the widgets now fit on our single sheet there. Okay, so I'm happy with that, so you could just OK to accept that, and then we could just switch over to the Toolpaths tab. And because we've got our parts set up where our toolpaths are associated to vectors on particular layers, all I need to do is recalculate all of the toolpaths. It's told me that all the toolpaths have successfully been recalculated. I could go ahead and press OK, and I could go and preview all of those toolpaths there.